Good. So domain was done. X-intercepts. I need to find the degree. The degree will tell me exactly how many intercepts I'm looking for.
3 and 2.
So what degree is that? You cannot just tell me, okay, the first factor is 3 and the second one. You have to tell me the degree of the polynomial, not piece by piece. The degree is 5. What is the maximum possible number of turns? 4. 1 less than the degree. How many x-intercepts would you find? How many x-intercepts? We're not talking about turns.
2. 3.
I heard 3. I heard 2.
2.
I heard 2.
Question?
I'll give you 5.
You have to give me 5 because that's the degree.
For you.
If the degree is 1 billion, we are looking for 1 billion x-intercepts. If the degree is 2, we are looking for 2. If the degree is 5, we are looking for 5. No matter how many times they repeat themselves, and that's a trick, right? Because when they repeat, it's a multiplicity, and I know what happens there. So if the degree is 5, I have to present 5 solutions. So x-intercepts, when y is 0, I have x cubed times x minus 2 squared equals 0, and I have to see 5 solutions. Absolutely mandatory. So even if they repeat themselves, and that's very important because that's a multiplicity, and I know what happens there. Yes, I'm ready. Very good. Which means multiplicity what?
3.
Of course. What will happen at that point, at the x-intercept, where the function has 3 solutions, x equals 0? How will the function look at that point? First of all, will it cross or will it turn? It will cross. Any odd multiplicity is a cross. What type of a cross? Like this or like this? Yes. So it's a cross, but slow. Cross, slow. Good. Anything else? Do we have anything else?
2.
Yes. X equals 2 twice. Very good. Multiplicity 2, what does that mean? What will the function do at 2, 0? It's an even multiplicity. For every even multiplicity, the function will turn, always turn. So this is a turn. So I will put in the chart 0 and 2. At 0, I will write cross and slow, so I don't forget. And at 2, I will write a turn. So y is 0 at those points. Okay, now I need the end behavior. So let's see, let's go through the list. So x-intercepts and their multiplicities. The y-intercept, it's very clear when x is 0. That's done already. Maximum possible number of turns is done. Max min with a calculator, range after I graph it, and symmetry. If a function crosses at 0 and then turns at 2, it cannot be symmetric. But I have to write that like f of negative x does not equal f of x, which means not even, and does not equal negative f of x, which means not odd. So the function is not symmetric. We're not talking here about a quadratic function that has an axis of symmetry. We are only talking about whether the function is symmetric with respect to the y-axis or potentially with symmetric with respect to the origin. So it's not symmetric at all. I need the end behavior. Does it do this or does it do this? So because the degree is odd, And because the leading coefficient is, right? Right? Okay, let's go back for a moment. The degree is odd. The degree is odd, and the leading coefficient is? The degree is odd, and the leading coefficient is? Clear? Yes? Okay, so let's go back. Where was I? Here. Good. So you told me that the end behavior is this. So that means negative infinity to infinity. I'm trying to make sense of the information I see. All my information is summarized. I don't have to look anywhere else, just the chart. Nothing else matters to me. So it's coming from negative infinity. It gets to the origin, crossing very slowly. One cross, but very slowly, approaching slowly. It's coming to definitely a maximum. Why? Because it has to come back at 2, 0 and turn again. Why it turns? Because the multiplicity 2, and then it's going to positive infinity. One more time. From negative infinity, coming to the origin very slowly, slowly, slowly. It crosses. If it crosses and it has to come back to a turn, it must have a turn again. A turn, it's coming down to 2, 0. It turns there. I know that, multiplicity 2, and it's going to positive infinity. Does it make sense? Yes? Okay, so let's graph. Here's my graph. So I plot 0, 0, and I plot 2, 0. It's coming from negative infinity, very slowly crossing at the origin. It has to go to a maximum. It has to come back and turn at 2, 0 and go into infinity. Yes, I'm also asked to find this maximum. So with the graphing calculator, so I go to the graphing calculator in y equals, delete everything, clear everything, and we had x cubed, x minus 2 squared, x cubed, in parentheses x minus 2 squared. And I'm going to choose the viewing window because I already have the graph, negative 5, 5, and negative 2, 5. So negative 5, 5 with a scale of 1. I'm going to say negative 2, 2, 5 with a scale of 1. And I'm going to hit graph. It's coming, crossing slowly, not like this, but very slowly, coming to a maximum because it has to come back and turn at 2, 0, going to infinity. So I have to determine that maximum. This one is a local minimum, 2, 0, and this one is a local maximum between 0 and 2. So second in calc, I want a maximum for from 0 enter to 2 enter, no guess, just give me the maximum. 1.12, 1.1, 1.12, 1.1. And I put them right here. If I'm asked now to find the range, what will be the range of this function?
What was your maximum? I mean, what did you do on the calculator?
1.12, 1.1. So you go to second and calc and choose 4, which is maximum. And then it's asking you for the left bound. So let's put 0, enter, and then 2, enter, and then enter again. Did we get 1.12, comma 1.1? Yes. 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 Good?
Right there.
Oh, 1.2. Thank you. Sorry.
That's what I got.
Oh, I'm sorry. Yes. Thank you. Sorry about that. Okay, range, please. One more time. What is the range of this function? From negative infinity, right? From negative infinity to positive infinity. Good. So the range, all real numbers. Very good. Questions? Okay, let's see if there is anything else we can do here from this test. And no, not yet. No, not yet. Yes. Okay, since we already had one, do we still want to look at rational functions?
Yeah.
Okay, fine. That's fine. So let's look at this. What type of function is it? Yes, very good. Where do I start? How do I start? Where is the starting point? I'm damaging equipment here. Where is the starting point? Yes. So let's look at the function and please tell me what is its domain. So the moment I identify that this is a rational function, a lot of lights come on in my head. Asymptotes, undefined, and behavior. A lot of things come on. Rational, not friendly. A lot of things that I have to work on, blah, blah, blah. Okay, so then. Let's look again.
Oh, can we cross out?
Not yet. Yes, the answer is yes, but not before I find the domain of the function I'm given. My hands are tied till I find the domain. Then I can do whatever I want. Exactly. Negative infinity to negative 2, negative 2 to 2, 2 to infinity. In other words, you are telling me which values of x will not be accepted for this function.
What do you say was negative infinity and 2?
That's why I'm emphasizing right now one more time, because I don't think everyone heard me. So that's why I'm waiting. So which values of x are not acceptable here? Do we all agree with negative 2 and 2?
Yeah.
Jesse?
Yes.
Okay. So then I have negative infinity, negative 2, 0 must be in the chart to infinity, and I have this. Because I know that negative 2 and 2 cannot exist. The function doesn't exist, so they cannot be plugged in. Is this okay? Yes?
Yeah.
Now I can do what? Jesse already told us, but not before I state the domain.
Okay, so cross out the.
And what do I get? What do I get at the top? That is why I always ask you, x minus 2 divided by x minus 2, is that 0 or is that 1? Because if you write 0, the whole thing collapses. Then we can go home.
1.
It's 1. So let me show you here one more time. This is very important. When I divide 2 by 2, 2 divided by 2 and 2 divided by 2, no, it's 1, right? So that's why. So x minus 2 divided by x plus 2 times x minus 2. Always write what you divide. I divide the top by x minus 2, and I don't get 0 but 1. I divide x minus 2 by x minus 2, and I get 1. And I don't want to see this. What is wrong with this? What was the error I made now? No?
Yeah.
Right. All of a sudden I said x minus 2 is not in the denominator because I don't want it there. I want to put it up. I can't do that. So So the numerator is what I see. What is it? Yes, and the denominator is what I see. I can't change. Yes, I can't change and move terms or quantities from the top to the bottom because I want to. Okay, is this clear? So the function we are looking at is actually f of x equals 1 over x plus 2. Agreed? Okay, so what does this say about negative 2 and 2? I have to clearly identify what's happening here. So what will I say about x equals negative 2? Very good. What will I say about x equals 2? Yes. Good. So once you say VA, what do I have to write here and here? Awesome. Once you say hole in the graph, what do I write here and here? Not infinity. What do I get? I have to plug it in. And the number has to be the same on both sides. Notice I cannot plug it in here. I have to plug it in the simplified form. So what do I get on the left? 1/4, right? 2 plus 2. And on the other side, it has to be the same. So then when I get to graph this function, the coordinates of the hole or the open point will be 2, 1/4. Awesome. 2, 1/4. Good.
Is there a hole because there's x plus 2 in the denominator?
The hole is not at its x plus 2, which is x equals negative 2 vertical asymptote. The hole is at 2 at the factor that went away.
Okay, got it.
So if a factor from the denominator goes away with an identical factor from the top, at that point there is a hole in the graph. If a factor does not go away with anything from the top and stays in the final simplified form, I can get rid of it, and it has to be a vertical asymptote. Is that okay, everyone? Okay, perfect. So now I need the signs. So with negative 2.1 and negative 1.9, I will plug them in here. So plug in and tell me the sign when you plug in negative 2.1 plus 2. Negative 2.1 plus 2. What will be the sign in the denominator? That's just a sign. Negative. So the top is always positive. Divided by negative, what will be the sign here? Awesome. Please plug in negative 1.9. What do we get? Positive, positive at the top, positive at the bottom, we get positive. Do we understand the negative infinity and the positive infinity? Okay, I plug in negative 2.1, a number from the left-hand side of negative 2, as close as I can. Negative 2.1 plus 2 is a negative number. I don't know what it is, I don't care. I only want the sign. Positive of a negative is negative.
What does that give us the answer for?
So the negative 1.9 plus 2 is positive. Positive over positive, that's how we got this.
Did you just say the negative 1.9 plus 2?
Is positive.
Oh,
2 is bigger and covers the negative 1.9. Negative 1.9 plus 2 is a positive number.
0.1 or something, so you have a positive number.
Is that okay? And so positive over positive will be positive. Is that okay?
Mhm.
Good. What type of function is this? We know rational, but which type? Is it 1, 2, or 3? Type 2. What is the horizontal asymptote for all type 2 forever? Which is always the end behavior.
I understand that.
Is it?
Well, yeah, I just need to understand, I got it now.
Better? Okay. So now I want to find the y-intercept. When x is 0, how much is y? 1/2. Very good. And where is this function 0? When is any ratio 0? So I have a fraction. When? When the numerator is 0. But is the numerator ever 0? No. So there are no x-intercepts. No x-intercepts. Good. So I'm trying to make sense of the information I have. It starts from approaching the horizontal asymptote. And then it drops down to negative infinity. Okay. On this side, from positive infinity, it crosses the y-axis at 0, 1/2. It goes through this point, 2, 1/4, and getting closer and closer to 0. One more time. On the right, from approaching 0 down to negative infinity. On this side, from positive infinity, crossing at 0.5, going through the open point 2, 0.25, and approaching 0 eventually. Does it make sense? Okay, so here it is. When I graph a function with asymptotes, I have to graph the asymptotes first. Yes. So there are two asymptotes. One is an overkill. You don't need to do this. I'm just trying to emphasize it. So the horizontal asymptote and one vertical asymptote at -2. X equals -2. 0, 1, 1/2, something here, and 2, 1/4, somewhere here, open. So from positive infinity, crossing, I don't know why I didn't start from the left, I'm sorry. So from 0 to down to negative infinity. I had no reason to start in the middle. I don't know why all of a sudden I started there. So from 0 down to negative infinity, from positive infinity crossing the y-axis at 0.5, 0.5, going through the open point 2, 0.25, and approaching 0 eventually. Any questions? Any questions? Yes?
The one like the third quadrant, like the one that's going down.
This one?
Yeah, there's a 0.
From 0 down to negative infinity.
And it's turning at the vertical asymptote.
It's not
Right
turning.
before the 2.1, right?
So this is the 2, 0.25.
Okay.
So we understand there are no max min here, right? Look at my marker, please, and tell me what is this function doing always?
It's going down.
Are there max min? Remember, max min means increasing,
Has a peak and then
decreasing, or decreasing, increasing. This function is decreasing all the time. No turns, no max min. It's always decreasing. Can anyone give us the range of this function?
Negative infinity
Awesome.
to -2. Union.
So negative infinity, I agree. Comma.
0.
Awesome. Union.
That'll be, is that -2?
I have to start where I stopped.
So you got 0.
0, comma. Be very careful now.
This goes both to -2.
There is a hole in the graph. From 0 to 1/4. Union. Awesome. Thank you, Natalie.
1/4.
Exactly. Tricky, isn't it? How do I know that that's the case? Look how I know. I cross the function with horizontal lines and ask myself, does it hit the graph? Yes, 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 yes. No. Yes, yes, no. Yes, 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 yes. So 2 open points in this graph. One which is 0 and the other one which is 1/4. Good. Okay, the other one. Since we already had a problem like this, if we have time, we can come back to it. I'd like to review other things. So can anyone just in one quick sentence, can you tell me what you're going to do here? First, rearrange it, and then it says when is the maximum height, blah, blah, blah. Find the vertex for part B. For the maximum, because it's quadratic, I will find the vertex. And here, yes, I will find the x-intercepts for part B. Let's look at problem 2. Let's read the question. Use the method of your choice to divide this by this and state if p of x is divisible by x minus 2. When we say something is divisible by, we say that number is a factor, right? So I say 9 is divisible by 3, meaning 3 is a factor of 9. What has to happen for a polynomial to be divisible by another polynomial? Say it again. The remainder must be correct. Say it again, Jessie. Yes. Both of them are in descending order. Both of them are in descending order. So what's next? Yes. So we want to, so the problem, one more time, I was just uploading one video. It's getting it started. So I'm asked, I'm given 2 polynomials. I'm given polynomial p of x, x to the 4th minus 4x squared plus 2x plus 5 over x minus 2. So here I'm asked, is x minus 2 a factor of the top, or is the bottom, is the top divisible by the bottom? So, and I'm asked, okay, use the method of your choice. What do you think I'm going to do? And what are the options? Let's look at this, think about the options and then choose the easiest. I can use long division, awesome. What else? One option, perfect. What is the second option? Synthetic division, because the denominator is such that I can use the synthetic division. If I put an x squared here, I cannot use the synthetic division, right? Or if I put 5x minus 2, I cannot use the synthetic. I can, but it's a little bit more difficult. Okay, good. So that's the second option. What is the third option?
Remainder theorem.
The remainder theorem. So I want the remainder theorem because it's the easiest. So if I want to identify whether x minus 2 is a factor of the top, I don't care for the quotient. Is it wrong? No, it's not. So if you use the long division and you get the remainder 0, what would you say? It's a factor. What if you use the synthetic division, let's say you get the remainder 15? Is it a factor or not? No. But it's a long process. How do I use the remainder theorem to simply show yes or no? It's a factor or it's not a factor? What should I do? Okay, let me refresh your memory on the remainder theorem. So if we have p of x divided by x minus a, which is the case we have, P of A will be remainder. So P is x to the fourth minus 4x squared plus 2x plus 5. And the denominator is x minus 2, or x minus a. So I want to find this. If this is 0, I will say x minus 2 is or is not a factor of the top. If the remainder is 0.
Is.
Yes. If I get the remainder P of A to be 15, what will I say again? Is x minus 2 a factor of the top or not? It's not. Good. So please tell me what to write. Plug it in. Plug it in. Minus 4 times 2 squared plus 2 times 2 plus 5. If this one more time equals 0, what do I conclude about x minus 2? Factor. If it doesn't, whatever other number but 0, I will say x minus 2 is not. Good. So how much is 2 to the fourth? How much is 4 times 4? Plus 4 plus 5. What is it? 9. So what do I conclude? It's not a factor. The remainder is not 0. X minus 2, not a factor. Or if you say P of x is not divisible by x minus 2. You either say P of x is not divisible by x minus 2, or you say x minus 2 is not a factor of P of x, whichever you prefer. So I will say not a factor.
So why did you
So,
go ahead.
no, I wanted to ask, can we still use the long division method? Or this
Yes, you can do that. You can do that. This is the easiest thing to do, though. Say it again.
And why did you put P2? Why did you plug in 2?
That's the remainder theorem. So if we look at the division of a polynomial by x minus a, and I'm only interested in the remainder, if I'm asked to find the quotient or divide, that's a different story. I cannot use the remainder theorem. But here I'm not asked to find the quotient. I'm only asked, is x minus 2 a factor of P of x? So by the remainder theorem, because the denominator is x minus a, or x plus a, in other words, then P of A will be the remainder by the remainder theorem. Is it wrong to use synthetic division? No, you will get the same remainder. And you will say no, because the remainder is not 0. I will say x minus 2 is not a factor of P of x. Good. Okay, where are we? That's the easiest way. But you can choose any method. It says you choose any method. So it's up to you. All methods are acceptable. Synthetic division, long division, or remainder theorem. Now, if the problem is asking us to use the remainder theorem, then you have to use the remainder theorem to show whether it's a factor or not. But this problem says use the method of your choice. So,
Are you going to specifically ask us to use one?
remainder theorem is very important. And it works only when the synthetic division works. If the synthetic division, don't forget your question, Kelsey. So if the synthetic division works, then the remainder theorem is applicable as well. If the synthetic division doesn't work, in this case it does not, then the remainder theorem doesn't work, so you have to use a long division. There is no other way. Yes, please.
Isn't this the remainder thing right here?
Yes, this is what we just did, P of A.
I just thought you said the remainder thing, if the synthetic division will work in the remainder thing.
I changed it. You probably didn't look. I changed this to x squared minus a all of a sudden in the middle of my sentence. I'm sorry. You didn't see it.
Yeah, that wasn't screen.
Yes, yes, I did. Sorry. It wasn't meant to be that way. Yes, Kelsey?
So it's expert, you can't use synthetic.
No. The synthetic division requires the denominator to be either x plus 5, x minus 3, x plus 15, x minus 2. But if it's x squared plus 5, You can't. Only the long division. The synthetic division has a limited applicability. Yes,
So
Damon?
x squared minus a right now, the way you got it.
You cannot use the synthetic division. So therefore, the remainder theorem doesn't work either.
Right. So what we did don't even work.
You had to, if you have this, you have to use the long division. There is no other way.
Shouldn't mess that up.
I did in the middle of the sentence. I'm sorry. I can erase it.
It's okay. You gotta say that right out.
Okay. I will use a different pitch when I do that, so you can look. Okay. Good. So next question. Problem 3. So we have f1 2x minus 1 over x squared minus x minus 2. We have f2 x cubed plus 27 over, I need to write them down because I don't have enough room there. You know, I write big. I have room for f3. X cubed minus 9x over x plus 2. And the last one, x squared plus x minus 6 over x minus 2. I copied them down. Before I even look at what the problem is asking me to do, okay, I'm going to identify what they are and which category they belong to. So I'm ready. First one. I'm sorry, what are they?
Rational.
All rational because they have fractions and they have x in the denominator. Awesome. Good. What type is the first one?
The second,
2. Why the first one is, oops. What is the first one type 2? The degree of the denominator is greater than the degree of the numerator. Then I know immediately what?
It's gonna be a horizontal answer.
Which one exactly? Always. 0 indeed. Y equals 0, horizontal asymptote. Good. The second one. The type of the second one.
excuse me,
Yes.
first one I don't understand. Why is y equals to 0? The leading coefficient is 2.
It's not type 1. You cannot apply the method for finding the horizontal asymptote from type 1 to type 2. You're thinking that the function is type 1. It's not type 1. You cannot find the leading coefficient over the leading coefficient. That's not the way we find the horizontal asymptote for type 2. So for type 1, yes. But for type 2 is always 0. The degree in the bottom is 2, the degree at the top is 1. So they don't have the same degree.
Yes, I think it's only when y equals 0, only when the degree at the top is less than the one
In the denominator, yes. When the denominator is bigger at infinities, the function will approach 0.
Yeah, so in this case, the degree,
So at infinity, the bottom will blow up. The numerator will be much smaller. So that's why small divided by big is 0.
I was looking at 2, not the degree.
You have to look at the degree. Because the degrees are not the same, it's not type 1. Is that okay? Good. Number 2, what type of function, rational function is number 2? Indeed. What do I know about type 3? Immediately. I did not find it, but I know it has a slant. Very good. The next one. What type is the third one? So let's look at the degree of the top is, and the degree of the bottom is. Which type is this?
Take 2a.
Unknown. It doesn't have horizontal, it doesn't have slant. We have never talked about anything like this, right?
Because
The degree of the top is 3 and the degree of the bottom is 1. No horizontal, no slant. We know nothing about this function. Good. Last one. Indeed, type 3. And what do I know about the type 3? Assuming nothing cancels, I will say for now slant. But I have to analyze things. Good. Okay, that was analyzing these functions. And now I'm ready to answer these questions. Which of them have vertical asymptotes? Which function has vertical asymptote or asymptotes? The first one. What will I do in order to identify whether it has vertical asymptotes or not? Say it again. No. So what?
X squared minus X times
Yes, I have to factor it out to find the domain. A rational function has vertical asymptotes where it's undefined. Good. So please tell me how to write the denominator. Very good. Do any of these factors in the denominator go away with an identical factor from the top? No. So then what will you conclude about this function for sure? X equals 2 and x equals -1, they are holes in the graph. No? Very good. Indeed. Awesome. Second function, f2. X cubed plus 27 over x squared plus 4. Does this function have a vertical asymptote?
yes.
That's a slant.
True, but the question is about vertical right now. You're right. Does it have vertical? When does a rational function have vertical asymptotes again? When?
What's the definition? Anybody say?
No. When it's undefined, but when is a rational function undefined? Correct. So when a rational function is undefined, it will have vertical asymptotes. But when is a rational function undefined? Only when?
X equals 0
Say it again.
and X equals 0.
No. When the denominator is 0. So can anyone read the denominator?
X squared plus 4.
Good. So the denominator has to be set equal to,
0.
right, in order to find what? In order to find, you're correct. In order to find what? What am I looking for? Awesome. So Natalie already said this. So how many real numbers I square and get -4? None. So is x squared plus 4 ever 0? Remember the graph of x squared plus 4. Let's see if it's ever 0. This is x squared. Which transformation I apply on x squared to get x squared plus 4?
That's
You raise that 4.
So does this cross the x-axis ever? X squared plus 4 is never 0. No matter what number you plug in, you have to square it. You get positive. Positive plus 4 is never 0. So what can you conclude about f2? Does it have vertical asymptotes? Because it's defined where? Everywhere. It's never undefined. It happens that this is a rational function that does not have vertical asymptotes. It's always defined. Give me any number. I'll square it. Plus 4 will never be 0. So no VAs. Yes, Damon, go ahead.
I was just writing down notes. When you have rational function is undefined, it will have virtual asymptote.
Yes, where the rational function is undefined, it has vertical asymptotes. When it's undefined, a rational function, when the denominator is 0. Okay, what about the F3, please? I'm kind of running out of time, so I just wanted to make sure that you look at adding, subtracting, multiplying, dividing functions and function composition. Evaluate a function, a sum, difference, product. Find the domain, not the domain of the composition. I will not ask you to find the domain of the composition. I will ask you to find the domain of sum, difference, product, and ratio, but not composition. So, and decompose a function. Okay? So you'll tell me what else you want me to do. Determine if a function is one-to-one given its graph. Find the inverse of a given function, the 4-step procedure, and use the graph to find the inverse of a one-to-one function, find its inverse. Distance and midpoint formulas, and the equation of a circle.
You don't have equations written on there for us, or do we need to know
This is the only equation, really,
that you'll have written?
that I would like you to remember. And the distance formula is the same thing, basically. So the distance will be x2 minus x1, everything squared, plus y2 minus y1, everything squared. Okay? And the midpoint is the average of x's, x1 plus x2 over 2, and y1 plus y2 over 2. This we discussed today with an example. This we definitely discussed. This we discussed long division. We didn't have an example today, but I think we are okay with that. The factor theorem and the remainder theorem, we just discussed that with an example. These we did, I think, enough. And this I think we did enough. So I wish I had 10 minutes to give you an example of each here. I'm sorry? 5, 6, 3, 3, 2, 3, 1, 2, 8, 2, 7, and 2, 6. Yes.
You said we need to memorize that one that was underlined?
The equation of a circle, the distance formula, the midpoint formula, and the vertex. Yes, please. Okay. Yes. So correct. So F3. Does F3 have a vertical asymptote? And if yes, where? 2 plus 2 is not 0. Yes. X equals -2 is a VA. And the last one, F4. X squared plus x minus 6 over x minus 2. I should have said here to factor the top. The reason why I didn't say it, we have to do it, is because x plus 2 is not a factor of the top. Because this will be x, and x plus 3, x minus 3. Yes?
Is it the one for the unknown that the vertical asymptote is equals to?
Yes, the question was if it has a vertical asymptote. We're not graphing it. So the answer is yes. Although I don't know what to do with it, I know it will have a vertical asymptote at -2. Good. So what do I do with this? Before I decide whether it has a vertical asymptote or not, I have to do something. I have to yes, yes. I wish we had more time in this class to practice more. I know. So the top. Good. I have to state, I cannot simplify before I write the restriction. Don't touch it, because if it's gone, then you're not going to have that hole in the graph. You must state the restriction before you simplify, always. So what will you say first? 2. And now I will do this. And remember, it's not ever 0, but 1. So the answer is x plus 3. Good. So does this function have a vertical asymptote? No, because the factor from the bottom went away. What will happen, however, at 2 comma, and you'll tell me the y. What will happen at this point when x is 2 and y is correct, and y is 5, 2, x is 2, right? 2 plus 3. You always plug it in the simplified form, correct? So 2 comma 5 will be a whole. So coming back, does F4 have a vertical asymptote? Yes or no? No. It has a hole in the graph. Very good. Part B. Which of these functions has a horizontal asymptote? We already wrote that. I took it away. So the first one has a horizontal asymptote. The second one does not. The third one does not. And what about the last one? It does not. So only the first one. Can anyone know? You already told me the horizontal asymptote is y equals 0. Which of part C is a repeat? Which of these functions, the last at the bottom, have a hole in the graph? Which function will have a hole in the graph? F4, I agree. Next question. Which of these function has a slant asymptote? So F2 will have a slant asymptote. What about F4? Remember something very important. In order to determine the slant asymptote, I have to divide. If I don't have anything to divide, which I don't, that is not a slant asymptote.
Why does F4 slant again?
Because it's type 3. It happens in this case in F4 that the function is the slant asymptote. It's a linear function with a hole in it. Finally, F. Which of these 4 functions will you graph? We are asked to graph 1. Which of these functions will you graph? Will you graph number 3? Absolutely not. Will you graph number 2? No. Will you graph number 1? No. I will graph 4 because it's a linear function with a hole in it. It can be easier than that. That's what it says. Graph whatever you want. So I will definitely graph the last one. It will be a straight line with a hole at 2 comma 5. Not because I'm lazy, but because I'm allowed to choose the one I like, and this is the easiest one to graph. So I have to plot 2 comma 5. 1, 2, 1, 2, 3, 4, 5. When I gave this test, I had about 20 students in a class, or I don't know, 18, something like that. How many students do you think picked the last one? Everybody else worked so much harder to graph. Of course, not the one that is unknown, but one from the other two. Okay? So the hole at 2 comma 5. When x is 0, how much is y?
5.
When x is 0, how much is y? Good. When y is 0, how much is x? When y is... I'm sorry. When y is 0, how much is x? Very good. Awesome. Here's the graph. So this is f of x. I'm going to just write f4, and you can copy it. Was this the easiest thing to graph?
Yes.
Because otherwise you need horizontal asymptotes, or horizontal asymptote, vertical asymptote, blah, blah, blah. This was the easiest. Okay, so I still have 6 minutes, so please choose. So all these were done, but please choose from here whatever you want. So you want to look at a circle, you want to find the inverse of a function.
Is that all in this packet that we know so far?
Yes, that's all we need, yes. And you must make sure that you are doing these problems as many times as you need to till you master them. Okay, one more time. We have 5 minutes left, something like that. So please, circle.
I have a problem with, on 2.7.
Yes?
C. No matter,
You decompose on the graph. To graph a one-to-one function. So, okay. So, I'm going to graph a function. Which you are going to see a lot in chapter 4. Is this function one-to-one? Good. Does it have an inverse? And the two graphs of the function and its inverse will always be symmetric with respect to the line. Awesome, very good. The line y equals x. Please give me two ordered pairs that I could use to graph the inverse. Very good, awesome. 1, 0, which is a reflection of this over the y equals x. Good. And 2, 1, which is a reflection of this. My graph is not perfect, forgive me. So here's the graph. You're going to see these two graphs a lot in chapter 4.
So it's gonna ask us, like, it's gonna give us points.
It's going to give you a function. It's going to give you points or a table, something like that, and asking you to graph both on the same coordinate system. Good. Anything else from here? We still have 3 minutes. And thank you for coming early. We have to make up in 7 more sections, 7 more meetings. One, it's going to be on Thursday. I'll give you extra time. And then after that, we have 6 more.
Is all the work that's due the 22nd on my math lab going to stay the 22nd? Because I missed something. Like, everything that's due the 22nd of April, is it going to still be due that day?
No. I have no idea at this point.
So
When we get closer, when we finish chapter 4, then I'll have a better idea. Damon?
just keep on working.
Okay, so are we doing anything here?
The inverse function.
Let's find an inverse function. So please give me a linear function, any linear function you can think of to find its inverse. Jesse, is this what you had in mind?
Yeah.
Okay, so f of x, let's say x minus 3 or 2x minus 3 over 4. What type of function is this? If it has x in the denominator, I will have to say yes. If it doesn't have x in the denominator, I will have to say linear. Good. Is the linear function 1 to 1? By the horizontal line test, the linear function is 1 to 1. So let's find its inverse. First step. Very good. Very good. Multiply by 4. Very good. Somebody has been doing a lot of work. I'm very proud of you. So, final step. Inverse 4x plus 3 over 2. Very good. Anything else?